Yeah, any doubts in yesterday's method?
Yes, sir.
Yes.
Sir, one problem I got, sir.
Which one?
D power 4 minus 4D plus 4 into y equal to 0. Sir, I think question is wrong.
Question may be wrong. Okay, I will check it. Okay. Now, let us see next topic. Solution of non-homogeneous higher order constant coefficient linear differential equations. Constant quotient linear differential equation. Previously what we have studied, homogeneous means in the differential equation right side function is 0. Now what is this is non-homogeneous, right side function will be there. Okay, see what is the procedure. Consider the differential equation. What is the differential equation? F of d into y equal to some function. Consider the differential equation f of d into y equal to q of x. This function is not 0. Okay, where q of x is not equal to 0. Q of x is not equal to 0. That is called non-homogeneous differential equation. Then how to solve this, how to find the solution? Solution procedure. Step 1, consider the non-homogeneous. You write here non-homogeneous. First consider the homogeneous differential equation of equation 1. Homogeneous differential equation of equation 1. That is, homogeneous means what? Right side function is 0. That is equal to 0. You take equal to 0. Equal to 0. Okay. And solve this equation 2 and let the solution be complementary function. Let the solution be complementary function. That is generally called C dot F or YC. Previously, for homogeneous differential equation, the solution is y of x. Now, since it is non-homogeneous, assume first consider the homogeneous differential equation, and find its solution. Be what is that? Complementary function C dot F or YC. Okay, this is the first step of the solving non-homogeneous differential equation. Now, second step. Now, find the particular solution. Find the particular solution of particular solution. It is represented by particular solution is represented by P dot I. Particular solution P dot I or YP. What is meant by particular solution? Does not contain any solution. Doesn't contain any constant. That is called particular solution. As we have seen in the previous problem, some boundary conditions will be given. Y of 0 equal to 1, y dash 0 equal to 1, initial conditions. We have evaluated the constants, arbitrary constants in the solution using those conditions. At last, we arrived at one solution which doesn't contain any arbitrary constant. That is called particular solution. Okay. Now, find the particular solution P dot I or YP using YP equal to 1 over f of d into q of x. 1 over f of d into q of x. Okay. See how to write this. What is our differential equation? F of d into y equal to q of x. See, what I am telling, this is just a procedure. A simple procedure. to find this one. Behind this procedure, lot of derivations are there. I'm not giving all those derivations. Procedure I am giving. If how to remember this y being this y, how to write this y equal to 1 by f of d into q of x. All of you remember, don't write like this. Y equal to take this f of d this side. That means q of x by f of d. Don't write like this. This is wrong. Why? Because f of d means what? Differential operator. Function of differential operator. Some derivatives are involved in f of d. That means if I write 1 by f of d means what? This 1 by f of d is operated on what? Q of x. I have to operate this 1 by f of d on q of x. That is the logic of behind writing this like this. Yp equal to 1 by f of d into q of x. This is the next step. Oh, I have written in the last page. Okay. Next, third step. The general solution of equation 1, that is homogeneous equation. The general solution of step 3. The general solution of equation 1 is that is y of x is complementary function plus particular integral, or that is nothing but y of x equal to yc plus yp. This is the general solution. This is the final answer. What is yc? This is solution of homogeneous differential equation, that is f of d into y equal to 0. And what is this is? Yp is nothing but 1 by capital F of d into q of x. Addition of these two is the general solution y of x. This is the procedure. Now, in this one, what you know already, we have learned how to find the solution of homogeneous. This part is over. Now the question is how to find this solution. How to find this particular integral. How to find particular integral. Now, finding particular integrals. The particular integral is depends on the function q of x. Finding particular integrals. See, this class is very important. Listen carefully. Finding particular integral. There are cases here. Case 1. If q of x equal to exponential function e power ax. Q of x equal to exponential function. Remember this. Q of x equal to exponential function. Then what is yp formula? Yp formula 1 by f of d into q of x. That is yp equal to 1 by f of d into q of x means what? E power x. Just if you have any doubts, I will give this explanation. See, for example, some equation is like this: dq minus 4 into y equal to something e power 2x. Then what is yp? Then particular integral is what I have written. I have to write 1 by f of d into e power 2x. This is q of x. Okay, this is q of x. You write q of x. That is 1 by what is f of d? dq minus 4, and what is this is e power 2x. Like this you have to write. That is what? 1 by f of d into e power ax. Now, what is the thing here? Now, operate 1 over f of d on e power ax. This is, remember all of you, one more important point I have to tell. See, d stands for what? Derivative, d by dx. D stands for what? D by dx. Then 1 by d stands for what? Exactly, integral of dx. So 1 by d is integration, means 1 by f of d is also represents what? Some type of integration. 1 by f of d is nothing but integration. Now, how to operate that? Now operate 1 by f of d on e power x by replacing, this is important. Okay, I will write here, by replacing d by a in f of d. By replacing d by a in f of d. This is very important. How to operate? This is replace this d by this a. Replace this d by a in f of d such that how? Such that If I replace d by a, this denominator f of a not equal to 0, then what is yp? Now 1 by f of a into e power ax. One can now f of a, d is replaced by a constant, a is the constant. So 1 by f of a means what? Some constant you will get, then you write 1 by f e power ax such that what is the condition? This denominator never 0. F of a not equal to 0. F of a not equal to 0. This is the solution. This is the solution. Any doubts? Now the condition is if f of a equal to 0, if f of a equal to 0, then above formula fails, right? Because f of a 0 means what? Denominator 0 goes to infinity. F of a equal to 0, then above formula fails. Above formula fails. Then what we have to do then? Now, if f of a equal to 0, then I'm writing again yp equal to 1 by f of d into e power ax now, right? How to manage this? How to manage this? See, all of you remember this point. The derivation is there. I'm skipping all those because time will not permit us. There are two big units are there: function analysis, complex analysis. Now, how to remember this? Put one x independent variable. Independent variable is what? X. Put 1x in numerator and take the derivative of f of d with respect to d. F dash d means derivative of f of d with respect to d, and write e power x here only, not on this line, above the line. Then what is this is x into, now replace again d by a, now replace again d by a, such that what you will get now? F dash a into e power ax such that how it will be, such that again denominator should not be 0. This principle is valid. Denominator not equal to 0. Now if f dash a is also 0, then yp equal to what you have to write? What is actually 1 by f of d into e power ax is there. Now f dash a is also 0 means already 1x is there now. Already 1x is there. Then you write x into x 2 times multiplied by 2 times and take the double derivative, okay, of d with respect to d. Then x square by f double derivative d into e power a. Now after taking this, replace this by a, d by a, replace d by a. Okay, I have replaced d by a such that what is the condition? This principle is valid when f double dash a not equal to 0, and so on like this, and how this formula is derived? This is, now you have to remember this formula. One formula is there. What is d stands for? D by dx. This implies 1 by d stands for what? Integral of dx. And now this is important. This is 1 by d I know, but 1 by d minus a is what? 1 by d minus alpha, say, you say alpha. 1 by d minus a alpha into q of x, or I will write here. That is 1 by d of q of x means what? Integral of q of x dx. Integral of q of x dx, this part. Now 1 by d of q of x integral, but 1 by d minus alpha into q of x, the formula is 1 by d minus alpha into q of x formula is, this is minus alpha, remember. You write plus alpha x, integral of inside e power minus alpha x into this function dx. This is the formula. And similarly, 1 by d plus alpha, if I take 1 by d plus alpha q of x, then if it is plus alpha, outside e power minus alpha x, inside plus alpha x into q of x dx. These are the two important formulae. Okay, whatever this is, whenever denominator is 0, we have used this principle to get this result. So this is shortcut formula I'm giving directly. Okay, and these two formulae are also useful. And how I derived this two formulae? Assume this as some y, 1 by d minus alpha into q of x equal to some y. Then what is this? D minus alpha into y equal to q of x. What is this? Is dy by dx minus alpha y equal to q of x. It is linear differential equation. Find integrating factor, find the solution. Then you will get this answer. Okay, that part is there. Now this is about e power ax. Any doubts? Any doubts? Once again, e power ax means first you apply 1 by f of d on e power x by replacing d by a. If it is not 0, that is fixed. That is the answer. If it is 0, what is the principle? Write 1x in numerator. X means independent variable. If the independent variable is t, you have to write t here. Okay. Now x by f of d derivative with respect to d. First derivative f dash d into e power x. Now again replace d by a. If f dash a is not 0, this answer is fixed. If that is also 0, then put one more x in numerator. That is x into x by double derivative. Like that you have to proceed until you will get the answer. And these two are the formulae. Any doubts? Are you there?
No doubt, sir.
Okay, case 2. Now case 2 is different. See, if q of x value is e power ax will be there. E power ax will be there. Okay, I will tell this one later on because b of x will be there. Q of x is sin mx sine function or cos mx or sin mx plus c or cos mx plus c. Cos mx plus c. See, the particular integral is defined for some particular functions only, some standard functions only. One is exponential function, another one is sine function or cosine function, not for tan, cosine, like that. Okay, now what is yp? Then yp equal to 1 by f of d into, see, I will explain for one function. It is true for all functions. It is true for all functions. Sin mx, if I explain sin mx, it is true for cos mx, sin mx plus c, cos mx plus c. The importance is only for this m, not the constant c. So this is q of x, that is equal to 1 by f of d into sin mx. Then this equal to 1 by phi of d square into sin mx. What is the meaning of here? Here f of d must contain f of d must contain d square terms. Okay, it is written as phi of d square. That's it. What is phi of d square? It is nothing but f of d. And why this representation? F of d is having what terms? Phi d square terms. That's all. F of d is having what terms? D square terms. Okay. For that purpose only, I have written this. Now yp equal to 1 by phi of minus m square into sin mx. That is how to operate. What is the operation? Replace. What I did? This d square is replaced by what? Minus m square. Replace d square by minus m square. Replace d square by minus m square in phi of d square. Okay, such that phi of minus m square not equal to 0. Denominator not equal to 0. This is the answer, fixed. So what is the method? Sin mx, cosine mx, sin mx plus c, whatever it is there, f of d must possess d square terms, first condition. Second condition is what? Replace d square by minus m square. Replace d square by minus m square. Remember, this is minus m square, not minus m whole square. Not minus m whole square. For example, I will tell one part. Yp equal to 1 by, for example, some d power 4 plus d square minus 1 into sine, I will take 2x, sine 2x. What is m here? I'm giving here m value 2. So minus m square value how much? Minus 4. So what I have to do? 1 by replace d square. I can write this is d square whole square. D square whole square plus d square minus 1 sine 2x. Yes, the function is containing d square terms. Now what I have to do? Replace d square by minus 4. Minus 4 whole square plus replace d square by this minus 1 sine 2x. So what is the answer? This is 16. 16 minus 5, 11. So 1 by 11 into sine 2x, that is the answer. This is the answer. Okay. For example, or if yp is, how this is, something like this, d minus 2 into sine 2x. D minus some 9 I will take. D minus 9 into sine 2x. Is f of d contains d square terms? No. So what I have to do? Get d square terms by rationalizing this. D plus 9 by d square minus 9 into sine 2x. Got it?
9
Okay.
square, sir, in the denominator.
Then you take 3. Done? Okay. D square, d plus 3. D plus 3 into sine 2x by d square. Now you write like this, d plus 3 as usual. What I have to do? Replace d square by what? Minus m square, that is minus 4 minus 9 into sine 2x. Sine 2x. Then what is this becomes? Minus 1 by 13. This d minus d plus 3 into sine 2x. So minus 1 by 13. What is d stands for? Derivative. All of you remember, capital D stands for derivative. So I will solve in this manner. So minus 1 by 13, derivative of this one is 2 cos 2x plus 3 sin 2x. That's it. This is the answer. If d terms are not there, get d terms by rationalizing that. Okay, this is the process. Now what is the condition here? Phi of minus this denominator never 0. If it is equal to 0, what? If phi of minus m square equal to 0, then yp equal to same procedure. 1 by what is this? F of d into sine mx. That is 1 by phi of d square into sine mx. Then what is this? This is, if I replace this phi of minus m square, phi of minus m square is 0, right? Therefore put 1x in numerator and take the derivative of this one with respect to d, sine mx. Sine mx. Then what I have to do? X by, again replace d square by minus m square in this derivative, sine mx. That's it. This is yp. This is yp, where phi dash of minus m square not equal to 0. Again continuation. If phi dash of minus m square equal to 0, then yp equal to what? Put 1 more x and take double derivative of phi of d square sine mx. Now again this is x square by replace d square by minus m square in this double derivative, such that phi double dash minus m square not equal to 0. This is yp. Right? Proceed in this manner. And the same procedure is applicable, same process is applicable for cosine mx, sine mx plus c. See, all of you, mx plus c, there is no importance for this c. Importance is only for this m, or cosine mx plus c. Cosine mx plus c. Okay, this is one thing. And case 3. Case 3. If q of x equal to x to the power of k, q of x equal to x to the power of k, x to the power of k, or some polynomial, okay, Now, then what is f of yp? Then particular integral is what? 1 by f of d into q of x. This implies yp equal to 1 by f of d into what is this? X to the power of k. X to the power of k. Then how to solve this? You write f of d as 1 plus some function of d, x to the power of k. Here what? Express f of d as 1 plus some function of d, as 1 plus some function of d. Okay. Then take this 1 plus function of d to the numerator, that is whole to the power of -1 whole power x power k. Then expand. You know this expansion I am giving here. You have to remember 1 plus x whole power n expansion. This is 1 plus nx plus n into n minus 1 by factorial 2x square plus n into n minus 1 n minus 2 by factorial 3x cube, and so on and so on. This is the formula. Okay, series formula, 1 plus x whole power n expansion formula, particularly 1 plus n, not some a plus x. Using that, expand this using the formula. Then what I am getting, this is 1 plus x whole power -1 expansion, that is 1 minus x, this is x, plus x square phi of d whole square minus and so on. This is x to the power of k, x to the power of k. This is x to the power of k, function of d into, function of d means what? Derivatives, plus function of d whole square into x to the power of k, and so on. This is the answer. This is the answer. I will explain this. If any difficulty is there in expressing this one, it will be clear in solving the problems. Okay. Next one, case 4. Case 4. If q of x equal to, now we have already studied e power x. E power ax into v of x. E power ax into v of x. That is product of two functions. V of x, where v of x may be x power k or sin mx or cos mx or mx plus c, whatever it is. Mx plus c, whatever it is. Then yp is equal to what? 1 over f of d into q of x. Into q of x. This implies, listen carefully, 1 by f of d. Q of x is what? E power ax into v of x. Into v of x. Previously what we did, only one function is there, e power x. Just we replace d by a. D by a. But it is not like that. When e power x is multiplied by x power k or sin mx or cos mx, like that, it is not that case, right? Then what we have to do, I will give here. First, 1 by f of d is operated on e power ax by replacing d by d plus a in d by d plus a in f of d. D by d plus a in f of d. Meaning is what? That is yp equal to 1. See, whenever operation is over, 1 by f of d operated means you write in front e power ax by 1 by what I have to do? Replace d by d plus a. Replace d by d plus a into v of x. Into v of x. Now this part is I can solve. Again, this is what? One new f of d. Right? And v of x is what? X power k, sin mx, cos mx. Already this is known method. This part is evaluate, can be evaluated using previous techniques, using previous cases. Because v of x is what? x power k or sin mx or cos mx. Like that you can evaluate. This is very important. This part is important. Done. Now how many cases over? Case 4. Now case 5. Case 5. If q of x equal to, you say, x to the power of k into sin mx, some x power k into sin mx. How to solve this? This is somewhat complicated one. This one, it depends on case 4. Then yp equal to 1 by f of d into q of x. This equal to 1 by f of d into x to the power of k into sin mx. Then what we have to do here? Listen. 1 by f of d x to the power of k. Sin mx can be written as imaginary part of e to the power of I mx. Is it correct? Is it correct? What is this? I will write here. E power I mx means what? Cos mx plus I sin mx. I sin mx. I sin mx. Therefore, the sin mx is what? Imaginary part of e power I mx. E power I mx. Now, this can be written as imaginary part. IEP stands for imaginary part of 1 by f of d into e power I mx into x power k. Into x power k. Then IP. Just what is this model now? What is this model now? E power ax. E power ax into v. This is the model. Just I am giving here idea. E power ax into v of x model. Then what is the procedure? I told you first. This e power ax is taken on f of d by replacing d by d plus a. What is the a value here? A value is here im. So d plus im and to x power k. That's it. This part can be evaluated. This part is easily evaluated using previous technique, using x power k model. That's it. This is yp. This is yp. No need to remember this. Process is important. No need to remember this formula. We have to apply the process. That is important. Whatever the points I stress, remember those points. Another one. What is that? If it is cosine, case 6. Case 6. If q of x is what is that? X power k into cosine mx. Then what is yp equal to 1 by f of d into q of x, 1 by f of d into x to the power of k cosine mx. So I have to write what cosine mx is what? It is a real part of rp, real part of e to the power of I mx. Now take the real part in front. Real part of what is this? 1 by f of d into I will write e power I mx first, then x power k. Then what is this? The logic again e power ax. This is e power ax into v of x model. So this e power I mx is taken on f of d as replacing d by d plus a. A value is what? Im into x power k. This part can be evaluated using our previous method. And see, in all this is yp. This is yp. And in this entire solution, after getting, I have to select what terms? Real parts only. I have to select in this entire solution, select real parts only. Done? And the last formula, case 7. Case 7. Okay. If q of x equal to x into v of x, just x into v of x. Okay. And what is v of x? This may be sin mx. Because you can apply this method, all of you. See, this x into v of x, I am giving specially. This x into, this is also x into v of x power k, k value 1. K value 1. There are some problems where we can use this technique. Okay. See, yp equal to 1 by f of d into q of x, 1 by f of d into x power k into v of x. If it is, they may be sin mx, cos mx, or e power ax. When it is e power ax, then you can apply our previous formula, e power ax into v of x model. But there is one short formula was derived. I'm giving that. What is that? So once again, I'm writing this one, yp equal to 1 by f of d into x into v of x. This formula is x minus 1 by f of d into f dash d. See, don't write f dash d in this place. Here only you write. That means what? First I have to operate f dash d, then 1 by f of d into 1 by f of d into v of x. 1 by f of d into v of x is applicable when f of d not equal to 0 when it is operated on v of x. That means this part. For example, this is 1 by d minus 2 into e power 2x. For example, what I told, e power 2x, this entire bracket into what is the e power 2x method? Replace d by a. D by 2 means this part 0. When this is 0, this formula collapse. Not applicable. Not applicable. If it is not 0, then you can apply. I will explain every case using one example. Okay. These are the complete methods. Any doubts? If you have still any doubts, those are clear in solving the examples. See. So, you take y triple derivative minus 2y double derivative minus 5y dash plus 6y equal to 4 e to the power of minus x minus e to the power of minus 2x, e to the power of minus 2x. Okay, now solution. What is the equation? Third derivative, double derivative, first derivative, and 6y equal to 4 e to the power of minus x, e to the power of minus 2x. First write the operator form. The operator form of the differential equation is, what is the operator form? Triple derivative, dq, double derivative, first derivative, and 6 and y comma equal to what? 4 e to the power of minus x, e to the power of minus 2x. See, right side function is not 0, is non-homogeneous, differential equation. So how to solve? Procedure. What is the procedure? First consider, don't forget the procedure. What is first? We have to, original procedure is what? First we have to solve homogeneous differential equation and let its solution be complementary function. Then find the particular integral. Then take the sum of those two. yc plus yp is the solution of equation 1. So first consider the homogeneous differential equation. Homogeneous differential equation of 1, that is d cube minus 2d square minus 5d plus 6 into y equal to what? 0. Equal to, right side function is taken as 0. You know how to solve this one. Auxiliary equation or characteristic equation is what? F of m equal to 0. F of d is this one. Okay. Here f of d equal to what? d cube minus 2d square minus 5d plus 6. That is equal to m cube minus 2m square minus 5m plus 6 equal to 0. Now cubic equation. So So definitely one root by using trial. One root by using trial. First root by trial. It's compulsory. By trial, put m equal to 1. 1 minus 2 minus 5 plus 6. 7 minus 7. By trial, m equal to 1 is the root. Now, you know synthetic division. Synthetic division. What is that? Cube quotient, square quotient, m quotient, and constant. And what is the root? 1. Put 0. 1 plus 0, 1. 1 into 1, 1. Minus 2 plus 1, negative 1. 1 into minus 1, minus 1. This is minus 6. 1 minus 6, minus 6. Adding 0. You have to get definitely 0 here. And what are these? This is the quotient of m square, quadratic. These are the quotients of quadratic expression. So 1 into m square minus m, 1 into m minus 6 equal to 0. So what are the roots here? I think m minus 3, m plus 2. Is it correct? Okay. Therefore, m equal to 3 comma minus 2. Therefore, roots are m equal to 1 comma minus 2 comma 3. Therefore, complementary function is complementary function of equation 2 is yc. Yc equal to how to 1. 1 is all are real and distinct. Real and distinct. Therefore, solution is what? For 1, e power c1 into, for minus 2, this part, for 3, e power 3x. Equation 3. This is yc. One part is over. Now, the particular integral is yp I have to calculate. Now, the particular integral is, what is that? Yp equal to 1 by f of d into q of x. So 1 by what is f of d? dq minus 2d square minus 5d plus 6 into, what are these? This is right side function is what? 4 into e power minus x minus e power minus 2x. Done? And remember here, okay, I will tell. Anyway, what is a value in the, let us split into two parts. This one split into two parts because right side function is having two parts. 1 by dq minus 2d square minus 5d plus 6 into 4 is a constant. I can write here, but don't write e power minus x here. Okay, I have to operate this. Minus 1 by dq minus 2d square minus 5d plus 6 into e power minus 2x. Done. So if I substitute what is a value here in this one, I am giving here e power ax. The a value is minus 1. So what is e power ax model? Replace d by a. So I have to replace d by minus 1 whole cube. Next one, 2 into minus 1 whole square, 5 into minus 1 plus 6 into e power minus x. And here I have to replace d by what? A value is what? Negative 2. Minus 2 whole cube, minus 2 into minus 2 whole square, minus 5 into minus 2 plus 6. Just e power ax model, this is case 1. Then what is this? 4 by, this is minus 1, this is minus 2, plus 5, plus 6, e power minus x, e power minus 2x, minus 1 by, this is minus 8, this is 4, minus 8, this is plus 10, plus 6, e power minus 2x. So this is 4 by, this is 11, 11 minus 3, 8. And what about this? Minus 16 plus 16, 0. I am getting 0 here. When 0 is there, what I told, this is 1 by 2 e power minus x. How to observe this when I will get 0? What is a value here? Minus 2. If that is the root of the auxiliary equation, yes, minus 2 is the root is there. Minus 2 is the root. Then definitely you will get, when I replace d by a, you will get 0 in the denominator. Then what I did, what I told, what is the formula? 1 by, I have to take what? Sorry, x by f dash d into e power minus 2x. That is the formula. So 1 by 2 e power minus x, x by, what is derivative of this one? Derivative of this one, f, this is f of d, f dash d, 3d square minus 4d minus 5. 3d square minus 4d minus 5 into e power minus 2x. Okay, 1 by 2 e power minus x minus x by, again what? Replace d by minus 2. Replace d by minus 2 e power minus 2x. Then what is this? 1 by 2 e to the power of minus x. X by, this is 4, 12. 12 plus 8 minus 5 e power minus 2x. So particular integral is what? 1 by 2 e power minus x, x by 20, 15 e power minus 2x. This is equation 4. Okay, therefore the general solution of equation 1, original equation 1 is what? Y of x equal to yc plus yb. That implies y of x equal to c1 into e power, what is that? X 1 minus 2, 3. 1 minus 2, 3. Sorry. C3 into e power 3x. And what is yp? Yp is what? Plus e power minus x by 2 minus x by 15 e power minus 2x. This is the answer. Any doubts? Yes, any doubts? Next, solve. In solved problems you can solve. I will solve exercise problems. Sign, yeah. Time permits, huh? Oh, what is the time now? 25. Okay, let me take one simple problem. Better. D square y by dx square plus minus 6 into dy by dx plus 9y equal to 6 into e power 3x plus 7 into e power minus 2x minus log 2. Minus log 2. Solution fastly. I'm writing directly. D square minus 6d plus 9 into y equal to 6 e power 3x 7 e power minus 2x minus log 2. Equation 1 is non-homogeneous differential equation. Non-homogeneous differential equation. So first consider homogeneous differential equation. What is that? D square minus 6d plus 9 into y equal to 0. Equation 2. What is the auxiliary equation? Auxiliary equation is f of m equal to 0. So this is f of d. F of d into y equal to 0 model, right? So this is m square minus 6m plus 9 equal to 0. So what are the roots? I think 3 na? Yeah, m minus 3 whole square equal to 0. So m equal to 3 comma 3. Repeated. Real and repeated 2 times. Repeated 2 times. Therefore, complementary function is yc equal to what? E power 3x. 2 times means what I have to write? Quotient as c1 plus c2x. This is 3. This is yc. Next, coming to yp, particular integral is yp equal to 1 by f of d into q of x. This implies yp equal to 1 by d square minus 6d plus 9 into what function? 6 into e power 3x plus 7 into e power minus 2x minus log 2. So split into three parts since three functions are there. 1 by d square minus 60 plus 9, 6 constant I can write here, plus 7 by d square minus 6d plus 9 e power minus 2x, and log 2 is also constant, so I can write in numerator directly. D square minus 6d plus 9, it is 1 here, right? Now first, what is the replace d square by 3? Already 3 is the root, remember 3 is the root, so definitely this denominator will be 0. You write 3 square minus 6 into 3 plus 9 e power 3x, and 7 by, this is minus 2 whole square minus 6 into minus 2 plus 9 e power minus 2, and this is log 2 is the constant, d square minus 60 plus 9. What you have to take, constant can be taken as e power 0x. The 0 is d value, a value now. Okay, now what is this? Is 6 by 0. I'm getting e power 3x, and for this I'm getting answer. This is 4 plus 12 plus 9 into e power minus 2x, and for this also log 2, replace d by 0. 0 square minus 6 into 0 plus 9 into 1. That's it, right? And what I have to do here, 6 by derivative f dash d, I have to take f dash d into x e power 3x plus 7 by, this is 1625 e to the power of minus 2x minus log 2 by 9. And what is f dash d? 6x by, what is f dash d? Derivative d square, sorry, d square, that is 2d. Next one, minus 6d, so minus 6 plus 9 means 0 e power 3x plus 7 by 25 e power minus 2x log 2 by 9, log 2 by 9. Next, again what I have to replace, d by 3, 2 into 3 minus 6 e power 3x, 7 by 25 e power minus 2x minus log 2 by 9. Again it is 0, again it is 0 e power 3x plus 7 by 25 e power minus 2x. Why again I am getting 0? Because 3 is repeated how many times? 2 times. The root is repeated 2 times. That is why 2. Then what I have to do? 6 into one more multiplication by x, f double dash d e power 3x plus 7 by 25 e power minus 2x log 2 by 9. Now 6x square by f double dash, already first derivative is here. One more derivative is what? 2d minus 6 derivative d, sorry 2 into e power 3x plus 7 by 25 e power minus 2x log 2 by 9. This is yp, that's it. This implies there is no d term now, there is no d term, so finished. This is 3x square e to the power of 3x, 7 by 25 e power minus 2x log 2 by 9. This is equation 4, yp. General solution is, general solution of equation 1 is y of x equal to yc plus yp. So what is this? This is implies y of x equal to yc means what? c1 plus c2x e to the power of 3x, and yp 3x square e power 3x, 7 by 25 e power minus 2x minus 1 by 9 log 2, 1 by 9 log 2. This is the answer. Okay, I think e power x model is clear now.
Yes, sir.
Yes, okay.